Chapter 3, Quadratic Equation in 1 Unknown Part 5. In this video, I would like to extend the number system from real number system to complex number system because we want to handle some cases in quadratic equations. If the quadratic equation has no real root, how can we also find some meaning or some values of x, so that we want to discuss that question more. But before that, I want to have some revision related to number system with you. First, what is the meaning about natural numbers? What is the meaning about positive number and negative number? And before that, I also want to emphasize what is the basic idea or basic meaning of rational numbers. First of all, I want to define what is the meaning about rational number first. In real number system, we have two main categories. The first one is rational numbers. The second one is irrational numbers. What is the basic definition of rational numbers? If the fractions, if the number can be expressed at P over Q, that means a fraction form. Remember, P and Q must be integers, so that this kind of number we can call rational numbers. So there are several examples, obvious example, which is rational numbers. First, integer. For example, 3 is an integer, so 3 can be expressed, which is equal to 3 over 1. So integer is rational numbers. And then how about fractions? Obvious, because this is the basic definitions. P over Q, which is a fraction, and P and Q are integers. This is a rational number. So 5 over 2 is also a rational number. And the second case is related to some decimal number. For example, if we have a terminating decimals 0.7 有限嘅點數. So simple, we can change to 7 over 10. This is a fraction form, rational numbers. How about recurring decimal? Or repeating decimal. For example, 0.33333. Some of you know this is also, we can also change to 1 over 3. 0.111, which is equal to 1 over 9. So all these four categories, we can also call that number is rational numbers: integer, fractions, terminating decimal, and recurring decimal. So if that number is not in this four category, we will call that as irrational numbers. That means we have infinite many decimals, but they are not repeating or not terminating. So two simple examples. For example, pi, we know we have infinite many decimal, and then not repeating, not terminating. And root 2 also. Root 2 is 1.41421356. We cannot find a pattern. So in the real number system, inside real number, we have two main categories. The first one is rational numbers. The second one is irrational numbers. Inside rational numbers, we can also divide into two main categories: integer or fractions. And then in integers, we also have three different types of integers. The first one is negative integers. Okay, maybe you can call it. Okay, this is negative integers, and this is positive integers. Remember, 0 is not positive, it's not negative. So if I ask you to find all the positive values of x, if one of the answer is x, one of the answer of x is equal to 0, you need to reject it. So in this video, I also want to extend the number system from real number to some number which is not included in the real number system. For example, square root of a negative number. So I want to introduce what is the meaning of imaginary number first, and then some basic operations of the imaginary number. Let's turn to page 8. First, I want to define what is the meaning of I first. I, which is equal to square root of -1. Why I want to introduce this term? Because I want to handle some negative square root. For example, -4, the square root of -4. I can change to 4 square root 4i. It is because I do not know how to handle the negative square root. So if I use I to replace this negative, then I know how to handle this negative square root of 4, which is equal to 2i. Then I also want to introduce some basic property of how to handle the emergent number. For example, example 3.15a, 2i times 6i, which is equal to 2 times I times 6 times I. We can change to 2 times 6 times I times I. So 12 I times I, you can see that means square root of -1 times square root of -1 I times I. So according to the basic property, square root of -1 times square root of -1, which is equal to -1. So which is equal to -1. It's equal to -12. So part B also simple. If you want to simplify it, maybe you can simplify it first, or you can also expand it. So which is equal to 11i and minus time negative I. So it's -11i squared. So -11i squared is equal to -1. So 11. How about I to the power 64? Maybe we can also make good use of some law of index. I know I want to change 64 to 4 times 16. Why? Because I know I times I is equal to -1. So I squared is equal to -1. So I to the power 4 is equal to -1 times -1. So which is equal to 1. So this is equal to 1 to the power 16, which is equal to 1. You may do the example follow-up exercise, and remember, pause the video and check the answer after you finish it. Okay, let's check the answer together. Okay, part A, -I times 2i, so we can change to -1 times 2, and then times I times I. So which is equal to -2 times I times I is equal to -1. So multiply them together is equal to 2. How about part B? 2i minus 3i is equal to -I, just like 2 apple minus 3 apple. And then 2i plus 3i is equal to 5i. So simplify it. -1 times 5 is equal to, this is -5. And then m times I is equal to -1, so -5 times -1 is equal to 5. Okay, last two example. I to the power 3 we can change to I squared times I. Because I to the power 3, that means we have 3i times multiply them together. I know how to simplify I squared, which is equal to -1. So -I. How about divisions? I want to use fraction form, and then by some simple calculations, simple cancellations, we make -3 I to the power 3. Then -3 I to the power 3, I to the power 3 is equal to I squared times I squared is equal to -1, so -1 times -3 is equal to 3i. Example 3.16. You may also need to know how to change the negative square root to be a rational numbers. I mentioned before, square root of -49 you can change to -49 times I, because I is equal to negative square root of -1, and then plus I, so which is equal to, and square root of 49 is equal to 7. 7i plus I is equal to 8i. How about second one? Square root of 4, simple. Okay, we can use the basic idea. And then square root of 4 is equal to 2. Square root of 100 is equal to 10. I times I is equal to -1. So -20. This is the basic introduction of the how to handle the number related to square root of negative number. We may have more discussion on our lesson.